Hello everyone, welcome to another Just Land Rovers video. This is more of a warning for you all. This video is 20 minutes long. It's probably, I think it's the longest video that we've done, and the ending isn't that satisfying. In fact, you'll probably see me again on camera like this. So it is interesting along the way, a bit more diagnosis for you guys, show you what we do every day. This is us in weekend mode on the sofa with the cat. Good afternoon everyone. So here we have a Discovery 5. This car would be under warranty, or it is under warranty. We've just been asked to have a quick look at it before it goes to dealership, potentially for any repairs. So this one has got ABS faults on the dash. That's about that really. That's all we've got, ABS fault message on the dash. Otherwise drives absolutely okay, no problems. It's actually a lovely colour. But anyway, enough of that. So this car is new enough that we need to use Pathfinder. Pathfinder is this module here. That connects into the car by the normal OBD plug and then connects wirelessly to the computer, which is nice, it's handy. It means you're at the risk of leaving Pathfinder in the car, but it's a big enough block that hopefully that won't happen. This is our Pathfinder kind of program on the computer. Here you can see we're in ECU diagnostics. We're looking at the anti-lock braking system, the control module. There's one trouble code, or one diagnostic trouble code in there, and that one relates to the front left wheel speed sensor circuit. It's saying open circuit, which could mean we've got a circuit short to ground or open circuit. That's what Pathfinder thinks. We've actually got Pico plugged in to something on the car as well, which I'll show you in a second, and I'll just explain why we're doing that too. Just by quickly looking at our wiring diagram. So in this dotted line at the left, we've got our ABS control module. This is page 2 of the ABS diagram. Page 1's on the other side. That shows us our power supplies from the battery, the fuses and relays and such, that then feed into the module. On the other side there's the sensors connected to that module. So module here, and then this one, remember we were looking at the front left wheel speed sensor. That's our sensor. You've got 2 wires to it, and they come back all the way to the module. There's no connectors between the two, it's 2 continuous wires all the way. We've got one that says power and one that says return. We're going to take that as meaning one is a power, as in power supply, and the other one is the signal. You can see power is they call it VT and WH, so that's violet and white, or purple and white, and the other one is YE. YE is yellow, obviously colour coded too, makes it nice and easy. So the fault code, or the description, circuit short to ground or open, we're going to hope to find something like a broken wire or a shorted wire anywhere along this. Now the wiring diagram doesn't show us where that wire goes. That's on us to know, that's on us to find out. Fingers crossed with it being a relatively simple circuit, as in we've got one connector block over here into the module and one connector over here that goes to the wheel speed sensor. There's nothing else in it. Hopefully there's not too many places to look. Now with that in mind, the only thing we have to think about is where is the module and where is the sensor. And if we have a quick walk around here, there is this is our ABS module. We've got 4 brake pipes coming out of it. These 2, which are the feeds from the master cylinder, but these 4 go off to each corner, and we've got a great big wiring connector block down the bottom. Oh, this is a connector block, sorry, and these are all the wires around the bottom of the module, up here into this chassis loom. And that's the module. Front left wheel speed sensor, remember? So here's our front left wheel. The wheel speed sensor itself is this. That comes up, follows around here, around the back there and here. So that connector is the only connector shown on the wiring diagram. That's the one that says it's the sensor, and it counts this wire here as being the sensor. It doesn't show you this wire and the sensor itself, it just says from this point onwards, that is the sensor. But we can just double check we're in the right wires there. So remember we've got violet and white, or purple and white, and a yellow. And these are our Pico back probes. and we'll go and see why we've got them plugged in there, or what we're doing with them plugged in there. Wiring diagram out of the way. Let's have a look at Pico. So, simple enough right now. We have a red wire. This one, that went all across the other side. And we've got a blue wire that also went across the other side. Those were the two probes, the back probes plugged in the other side. Our blue wire was plugged into purple and white from memory, and red was plugged into the yellow. If we take them back over that side, that means that our blue should have whatever our supply voltage is, the power, and red, sorry, should have the return or the signal. Now the wheels aren't turning, so we're not getting any signal whatsoever, but that's normal. We've actually got a little bit of noise, as in on the blue there, that's our positive. Got a bit of noise, but that's because we've got this connected up. If I'm just going to turn that off, and I'll show you what happens. So I'll turn it off now. That noise disappears, so all that electrical disturbance in the circuit has gone now that we've turned the charger off, and we'll just keep it off for now. So this shows us here, if we zoom in on the left a little bit, we're looking at something like just over 12 volts supply and close to 0. We'll just check our scale on the other side. Close to 0 for our ground, so we've got a good power and a good ground at the moment. We're just gonna let that refresh the page and stop it for a second, and we'll just zoom in on our red here. Now that's zoomed in, so obviously it's a lot messier, but we can follow it across, and we're somewhere between. In fact, tell you what we'll do, we'll use a little cursor here, drag this down from the top, line it up with our red, and that tells us exactly the voltage we've got. It's 1.29 millivolts, or 0.1-ish volts. Let's zoom back out again. Ideally for a ground, we would want something more like under 0.1 or under 100 millivolts, but we're in the region where we should be looking, so for now we'll just forgive it. We'll just quickly check our positive as well. Zoom in on that. Again, it's a little bit messy now we've zoomed in, but again, for now, ignore that. We'll drag our cursor down, somewhere like that, and 12.2 volts for a positive feed, and nearly 0 volts for our ground. So for now, again, we're going to ignore the fact that they're slightly messy and our ground isn't a perfect ground, and we're going to ignore it because I've already figured out what the problem is and there's no point looking at it. So red is ground, very close to 0, should remain at 0 unless we turn the wheel potentially, because that's our signal. Remember, this should remain the same, our power, and the signal should change if we turn the wheel. We're not going to bother doing that because, again, I know what the problem is. I'm going to show you what it is. Back to wiring diagram. Remember, we were looking for a fault anywhere along this wire that would result in an open circuit, or that signal not reaching the module. It should have a 12 volt and it should have a 0. So we're going to have a quick wander background to where the module was, not the sensor, but the module. And I'm going to reach my hand down here onto this wiring loom here, and I'm going to show you the screen and what happens when I move these wires. And I'm going to quickly show you the screen. Can we see that? Let's let it refresh. Refresh the page. There we go. And I'm going to wiggle that connector. Oh, look what happens to the red. We lose our ground connector. We lose our ground. We lose our ground when I wiggle that bunch of wires. So somewhere in there we've got our fault. I'm just going to pause it again. So that's what we've got. That's wiggle the wires once, wiggle it twice, wiggle it 3 times. Focus, well done. We could, if we wanted, just zoom in on one of those. I'll zoom in on that one. So you can see we started off here, 0 volts, that's our good ground. When I wiggled the wires, that what should be ground, what should be 0, went all the way up to, and I'll drag our cursor down again, something like 11.5 volts. A bit further along, came all the way down to 10.8, a bit further down again, 10.3. So what should be 0 volts has, when you wiggle those wires, suddenly become very nearly 12. Voltage, measuring things in volts, as in as a unit of measurement, is fine, but what we really mean by volts is potential difference, the difference between those two voltages. And this system at the minute is looking for a difference of, well, we'll call it 12. We've got 12 volts going in, we should see a difference of 12. Between 12 and 0, there's your 12. And what we were getting was, at 1.5 volts, under 1 volt. So not the correct potential difference that we should be getting. That will trigger our open circuit. There's no difference between the two voltages. It's not a short to ground, it's just an open circuit, but that's what we're looking for, an open circuit fault. Exactly what the problem is, as in what is it that happens when I wiggle that connector, or wiggle the wires next to the connector. That's challenge number 2. We found out what the problem is, we found out where it is. Now we need to find out how we're going to fix that problem. It might be, you know, 2 chafed wires inside that connector, or 2 chafed wires inside the wiring loom. It could be the connector block's cracked. It could be a pin is backed out. It could be the actual the circuit board inside the module itself, where the pins connect onto the circuit board, could be cracked. Anything like that. At the minute, I honestly don't know. So I'm going to get stuck in there. I may find the problem, I may not. There may be more to this video, there may not. But that's a little bit about how we would diagnose a problem like that. It's fairly straightforward when you think about it. Look at the fault code, follow the fault code, use your information that you've got, like a wiring diagram, and then figure out a way to isolate whatever fault you've got. Could have been a sensor, could have been a break in the wiring, could have been the connector block by the wheel speed sensor itself was knackered. As it happened, it's more like the other end, the module end, and obviously there's quite a lot going on in there. You've got, as I say, the wires, the pins, the circuit board itself. So I'm going to get stuck in, see what I can find. If there's something interesting, I'll show you guys it, and if not, that's it for now. Cheers. You guessed it, there's more. We haven't found the exact problem yet, but we have found a couple of issues. So I've taken this connector, I've taken it off the ABS module. I've taken the locking section off as well. You have to get quite close to see this, and I have to point at it with something really pointy. But if that will just focus. Right, there is a wire. There, a wire that's just worn through. And the one next to it doesn't look, it looks kinked almost. Now that's not the wire that we're looking for. But as in, it's not one of the 2 that goes to the near side front wheel speed sensor. But if we think that at least in this area that I was wiggling, there is one issue of a chafed wire, there could be other issues. So we're gonna carry on looking, see what we find. Okay, so we've got our problem isolated a bit more. We've still got this section, the lock, we've got that off the connector block, and we've got the connector block itself pushed back onto the module, so the module is now live again. We've got Pico recording, and this is actually quite hard to do, so I'm probably gonna drop my phone while I try and do this. But first of all, we'll just get you down there. Right, we've got the yellow wire there in the centre of the screen, and the white, or the purple and white as well. Those are the 2 wires that we were talking about before. They come up out of there and go off into the loom. It's that twisted pair. So now I'm just gonna grab hold of the yellow one only, that's this one. Not touch anything else, just that yellow one. And we'll see what Pico does. So I'm going to wiggle it. There you go. Wiggle, wiggle, wiggle. That's me doing this with the wire, just the yellow one. And obviously now, oh, there you go. So we'll just stop Pico and have a quick look at that. It's just so you can see exactly what's going on. So that's this yellow wire. Every time I pull it, we get boop, 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 boop. So that's that connection dropping out. Why it drops out, we don't know, but we know it's that yellow wire, and we know it's inside the connector. So inside that connector block, on the very end of the wire, is a small metal little terminal. It's a female kind of, it's like a female hollow connector, a female hollow terminal. That's bonded onto the copper core of the wire, and then that terminal slots over a metal pin inside the module. There's a lot of connectors in that module, a lot of terminals in that connector, maybe 30 or so, and each one has got a corresponding pin that it slots onto in the module. At the minute, from the feel of it, it looks like it's the terminal on the end of the wire rather than the pin on the module, which is probably the better thing for it to be, because if the pin in the module was broken, that would be either a module repair or a new module. As it is, we should just be able to get the remove the connector block again as a whole, extract that one wire, maybe put a new terminal on the end, and then refit the whole thing and try again. Or alternatively, get the wire and the terminal out, cut it off, then solder on an extended piece of wire, and then put a new terminal on the end of that wire, and then reinstall it. Other than that, that's what we've got. We've got the D5, still in that lovely colour. We've got Pathfinder and we've got Pico. And that's my Friday evening sorted. See you later, everyone. Thank you. Still not done. Okay, we've changed tools. We've just done our normal digital multimeter. The black wire here goes off to the far end, the wheel speed sensor end of our yellow wire, and our positive or our red wire here comes to this end of the yellow wire. We've taken this metal terminal that was inside our big connector block, and the object of this little test is to make sure that the wire itself is okay, just to double check the wire all the way from the terminal through the car loom all the way to that wheel arch, and to make sure that the connection between the wire and the copper core of the wire, which you can just see crimped onto this terminal, make sure that the wire is okay, the copper core where it's crimped onto the connector is okay, to try and just to narrow down again or rule out where our problem is. So at rest there we've got under half an ohm of resistance. That includes the resistance of the cables, as in my measuring cables. So I'm just going to hold this together here and wriggle and pull and everything that, so you can see the whole thing at once. Basically no changes. So it's not a problem with the yellow with the yellow wire itself. It's not a problem with where the core goes into this terminal. So the joint, effectively, the joint between this terminal and the wire is okay, and the wire is okay. So all that we're left with is the joint where this terminal gets pushed onto, and you may go upside down here. So those are all the pins, if it would focus. It won't focus. There. Those are all the pins inside the connector block, inside the ABS module, sorry. So what we have, we still haven't ruled out a module fault, specifically a module fault, but we're down to the joint between this terminal and the pin. So as that pin sticks out, this terminal slots over it and is meant to grip onto it, and that's where you get a good contact. We've either not got a good contact there, or it's the module itself. that's narrowing down or isolating this fault even further. Well, so what did all that mean? Because this is the unhappy ending of this video. Yeah, the ground path for that circuit is provided by the module. Without the ground path, we don't have our 0 volts. When we lose that 0 volts, when we lose the ground path, that's when our potential difference reduces to nothing. So when we approach 12 volts at the ground path, we've lost the ground path. What that means in this instance was, as the ground path is provided by the module, we were losing the connection to the module, and the fix was the joint between the little metal terminal and the pin. The pin and the module were fine. The connection between the two was at fault. And as I said in the video, the fix would be replace that terminal. Whether there was spare wire available on that yellow wire to just cut the terminal off, replace it with another one, or the alternative would be, as I said again, cut that wire and extend it with a piece of wire with a new terminal on the end. But that's it. That was the fix. That's the conclusion of this video. I hope you all liked it. Replacing that terminal would give us a good ground path to the module and keep that potential difference at a level where it should be. That's it. It's unsatisfying. It's not what you wanted to see, but that's it. Anyway, have a good weekend, everyone, and cheers.